Materials. Each mesh you create can have a different material or share materials with other meshes. To code along with this video, go to the folder Start Lecture 8 and open the file app.js. The first material we'll use is Mesh Basic Material, and this type of material takes a colour value and paints every pixel where the mesh shows this colour. It takes no notice of lights in the scene. Try changing the colour value and reviewing the results. Remember, colour values are a hexadecimal value, where A represents 10, B 11, up to F 15. The first two digits in the value give the red component, the second two the green, and the last two the blue. A value of FF is actually 15 times 16 plus 15 equals 255. 0xFF0000 means maximum red and minimum green and blue. 0x00FF00 would result in maximum green and minimum red and blue, and 0x0000FF would be maximum blue and minimum red and green. The simplest material that supports lighting is Mesh Lambert material. The Lambert model of lighting calculates the lighting at the vertex and then interpolates this value across the triangle that's being rendered. Regardless of the complexity of a mesh, it's actually made up of lots of triangles, and a renderer works on each triangle when building up the final image. Because lighting calculations are at the vertex level, Lambert lighting cannot show specularity, shiny bright points of light. To show the torus knot mesh using Lambert lighting, simply change Mesh Basic Material to Mesh Lambert Material, and you don't need to do anything else. If you want to see specular highlights, then it's time to use the Mesh Phong material class. Change Lambert to Phong. When using Phong shading, if you want a shiny appearance, then you'll need to add some options to the object passed to the constructor. Enter specular 0x444444, shininess 60. Now the mesh appears shiny. But the material that is most commonly used these days is the Mesh Standard material. This is very complex. To achieve a shiny result, you need to adjust the roughness and metalness values. A great way to review the properties of the material classes is to enter material in the Three.JS org documentation search box. If we look at the page for Mesh Standard material by clicking on the name in the left column search results list, then we see a Three.JS app running on the page that includes a DAC GUI panel, allowing you to dynamically manipulate the properties of the material. The panel is split between material and Mesh Standard material. This is not because the mesh has two materials, it's because the Mesh Standard material class extends the base class of material. All Three.JS material classes are extensions of the material class, and here you can see the properties that are common to them all. Notice if you set opacity, nothing happens until you set transparent to true. Check what happens with the depth test and depth right options. Because a torus knot has triangles hidden by other triangles within the same mesh, using both depth test and depth right is essential. Depth right ensures each rendered pixel saves the distance from camera for that pixel to the depth buffer. Depth test decides whether when rendering a pixel to check the depth buffer and only paint the pixel if the current distance of this pixel from the camera is less than what is already saved in the buffer. Try changing the side option. Notice that choosing backside shows the inside of the mesh. Now open the Mesh Standard Material panel and adjust roughness and metalness to see how they behave. Flat shading turns the smooth surface into a faceted one, and wireframe changes the render to an outline version. A Mesh Standard material can have several textures applied. Try playing with them. Env maps control how the surface reflects and refracts light. Map replaces the colour with a texture. Roughness map allows you to control the roughness of the surface using a texture. If using an alpha map, a texture defining the transparency of the surface, remember to set transparent to true, otherwise nothing will happen. Using geometries and materials to create meshes is at the heart of a Three.JS scene. But sometimes primitive and constructive geometries are not enough, and you'll want to load a geometry that you've either created or found online. That's where loaders come in, and we'll review them in the next video. See you there!